Hello and welcome to today's lesson. Today we are focusing on factoring by grouping, and our objective for today to practice that is that you, all the mathematicians, can factor higher degree polynomials by grouping. So as we get started today, there are of course some essential pieces that we should have our focus on as we move forward. One of the things that we should have in the front of our minds is most of this chapter we have spent factoring squares or polynomials that have a squared term or the highest degree of 2. And we need to remember that there are polynomials that have higher degrees than 2 or have higher exponents, and we can still factor those higher degree polynomials. And so what we learned today will help us out with that. As we look here, in lesson 8.6, which was just a couple days ago, we factored trinomials that were ax squared plus bx plus c, and we did that by writing bx, or the center term, as a sum of two monomials. So we found some factors that multiplied to equal c but added, or multiplied to equal ac but added to equal the b, and then we split the bx up into that. And then we grouped our terms in pairs. We kind of split our problem down the middle and factored to two separate sets to look for the binomial factors for our answer. That process is actually called factoring by grouping. So we have actually already done this, not with the higher degree polynomials, but we have factored by grouping. And so we can use this technique specifically when we are looking at higher degree polynomials. So we are going to see that here today. As we start here on problem number 1, what is the factored form of 3n cubed minus 12n squared plus 2n minus 8? So when I look at this first question, okay, I do already see 4 terms there, and so I am going to kind of split it down the middle like we did before. Eventually, we do want to not be drawing that line down the middle, but if it helps us at the beginning here, we can use that as a tool. When I look at the first half, 3n cubed minus 12n squared. When I look at that, I do know that I can factor a 3 out of both terms, and I also see that they both have an n, and actually both have at least n squared, so I can factor that out as well. And so for this first one, I can factor out a 3n squared, and I can then, my first binomial, I will have left an n by itself, and a minus 4. On my second one, I can factor out a positive 2 and be left with n minus 4. So I've got my n minus 4 as my common binomial, and then my other binomial would be my two factors, 3n squared plus 2. And here I now have my polynomial factored. All right, go ahead and take a look at the got it question. Please pause your video, and if you, when you are ready to check your answer, resume the video, and I will put the answer here on the screen. All right, welcome back. When you are, like I said, ready to check your answer, here it is, 2t squared plus 5 and 4t plus 7. You can reverse those binomials. It is not a huge deal at this point. But you do need to make sure you have them with the same signs as written. If you have questions about this or are unsure how I got that, please pause your video and raise your hand, and I will be happy to help you. Otherwise, let's continue on to problem number 2. When we see problem number 2, one of the first things that I would like to point out is when it says factoring completely. It says that in the heading, and it says that in the directions for this problem specifically. When it says factor completely, that means we want to have nothing left unfactored. So if we have something that has a 2x and a 4 in parentheses, even if that's a binomial and it is actually a factor of the polynomial, we still want to factor out that 2 and not leave it unfactored. So that's what that means, factor it as much as possible. So we might end up with more than just 2 binomials as our answer here. So let's take a look at this problem. Again, we are factoring completely. So I am going to go ahead and start off by splitting the problem in half like we have been. And I'm going to factor it to the best of my ability. So 4q to the 4th power minus 8q to the 3rd power. I can factor 4q cubed out of both of those. And when I do that, I end up with q, and I end up with minus 2. When I look at my second part here, I can factor out a 12q, and so I can do that and end up with q minus 2. So now I have q minus 2 as one binomial factor, and 4q cubed plus 12q as my second binomial. Now, when it says factor completely, I want to verify that there's nothing else that I can factor out of these binomials. When I look at the first one, the q minus 2, it looks great. I can't factor anything out. I could factor a 1, but that literally will change nothing. So that one is good to go. But when I look at the second one, I notice that I have 4 and 12, and that right away tells me I can factor out something. So when I focus here specifically on the second binomial, 4q cubed plus 12q, I can actually factor out 4q. At that point then, I have q squared plus 3. And I, of course, cannot forget about my other binomial that is still part of my answer. And again, I just want to double check, is there anything else that I can factor? Q squared plus 3, there's nothing I can factor, and q minus 2, there's nothing I can factor. So that is all that I can do here. Okay, now I do want to show you one other method for factoring problem number 2. Okay, so I'm going to erase this work here and start over. The other method, instead of starting off by splitting the problem in half, there is something else that I can do. When I look at this problem at the very beginning, I notice that every single term has a q, and I also notice that every term is divisible by 4. So I can actually start off by factoring out 4q at the very beginning. I end up with 4q times q to the 3rd minus 2q squared plus 3q and minus 6. Now, at this point, once I have factored out that 4q, I'm going to leave that 4q in the front, but what I have in parentheses, I am going to treat as I have in the past and kind of divide it in two and factor that way. So I've got 4q out here in the front. In my parentheses currently, and I'm going to make brackets because I will end up with other parentheses inside here. In the first half, I can factor out a q squared, and so that leaves me with q minus 2. On the second half, I can factor out a 3, so I'm going to do that, q minus 2 once again. So for that answer, I've got my 4q still hanging out here in front, I've got my q minus 2, and I've got my q squared plus 3. You will notice that that is the same answer. If you had written down the first method, you should be able to compare this here and see that it is the same answer. While it might be written in a different order, I still have the same polynomials being multiplied, and again, they are still in their most factored form. There's nothing else that I can factor out of anything here. So go ahead and take a look at the got it question here. When you are ready to check your answer, you can resume your video. So go ahead and pause. When you're ready, resume your video, and I will show you the answer. All right, welcome back. So again, hopefully you were paying attention and noticed that it does say factor completely. And so at this point, you should have factored completely and gotten 3h times h squared plus 2 times 2h plus 3. If you have questions, please, once again, pause your video, raise your hand, and I would be more than happy to help you. All right, so my third question. The toy shown, and maybe you've seen these toys before, the toy shown is made of several bars that fold together to form a rectangular prism or unfold to form a ladder. What we are trying to find an expression that represents the dimensions of the toy when it is folded up. So we have the volume. V equals 6x cubed plus 19x squared plus 15x. And my job is to factor. Now, as I'm factoring, I've got a couple of methods here, so it just kind of depends. 6x cubed plus 19x squared plus 15x. Couple of things that I can do. I could factor some things out first, and so I am going to go ahead and do that. I can factor out an x and have 6x squared plus 19 plus 15. I'm sorry, I forgot the x with the 19. I apologize. And at this point now, I can treat it as I have in the past. I can try to figure out 6 times 15. I apologize. 6 times 15 is 90, so I can figure out what factors of 90 add up to equal positive 19. So I can think through the factors 1 and 90, 2 and 45, none of these are going to add up to 19, 3 and 30, still not going to add up to equal 19, 5 and 18, I'm getting a little bit closer here, 6 and 15 are factors of 90, but still not adding up to equal 19, and then I've got 9 and 10, which do add up to equal 19. So I've got my x here out front. I've got 6x squared plus 10x plus 9x and plus 15. At this point, I can apply my prior knowledge, split that in half, and continue factoring here. X on the outside, from my first half here, I can factor out a 2x. And that leaves me with 3x plus 5. In my second half here, I can factor out a 3, and that still leaves me with 3x plus 5. So at this point, I have x times 3x plus 5 times 2x plus 3. And I do want to verify that I have everything factored completely. I don't see any more factoring that can happen here. So my three factors are x, 3x plus 5, and 2x plus 3. In the context of this problem, because it was talking about the volume here originally, and you can see that here in that formula, because it wasn't originally talking about volume, I know that the volume of a rectangular prism is length times width times height. And so these dimensions, while I don't know which is which, I do know that these three dimensions represent my length, width, and height. All right, once again, you do have a got it question, so please pause your video, give the got it question a try, and when you are ready to check your answer, please resume your video. All right, welcome back. Your answers for your got it. We have 3 dimensions, and because it is asking us for the possible dimensions, I do not need to write it as a product, or I do not need to write it as the multiplication problem. However, if you did, I completely understand that. That would look more like this. If you had it written that way, and again, these two could be flip-flopped depending on how you did your problem. If you did it that way and had that written down as your answer, you still have the concept, you still understand what you're doing, and so this is perfectly fine at this point. We do want to pay attention to the context and notice that it does say what are the possible dimensions, or what can represent the dimensions of the prism. And so the 3 possible dimensions are the individual polynomials. But it's all good. We will get there. At this point, okay, just a quick review or summary of what we have done so far. We have factored out the greatest common factors. That's kind of where we started with this factoring chapter. If a polynomial has 2 terms or 3 terms, we've looked for difference of squares, perfect squares, binomial factors. We've done all kinds of things. When we've had 4 or more terms, we have today specifically looked at grouping terms and finding those common binomial factors to factor in that way. And as a final check, it is always good to think about that factoring completely idea where we make sure that there's no other factor than 1. So we just kind of want to have these things in our mind here as we wrap up factoring polynomials. At this time, you are ready for your practice, so please go ahead and stop your video and show me your notes page that you have completed this lesson in order to receive your assignment.